All right, let's do this. Derivative of e to the x and a to the x. Remember, tangent slope generator for e to the x is e to the x. Crazy, but it is. Tangent slope generator for a number to the x is a number to the x to the natural log of that number. Don't forget your rules. All derivative rules will still apply. Product rule, derivative of the first times the second, plus derivative of the second times the first. Rewrite it if you wish. Factor out the e to the x if you wish. Something we'll be prepared to do if we are doing a function analysis. Not necessary for this, though. Quarter rule. Derivative of the top times the bottom minus derivative of the bottom times the top, all over the bottom squared. Simplify the top, maybe. X e to the x over x plus 1 squared. Now we got to worry about chains. So with e to a power, with the power not being x, it's e to a power is the outside, the inside is the negative x. So the derivative of e to the x is e to the x, the derivative of e to a power is e to the power, the derivative of x is -1. So for this one, it would be e to the negative x times -1. Remember, the power is just whatever started inside of it. So that's just negative e to the negative x. We'll see that often. If I have an x in front of the e to the negative x, I have to use the product rule. You don't just go straight to the power rule. It is a product of two functions. You use the product rule. Derivative of the first times the second plus derivative of the second times the first. Maybe factor out the e to the negative x. You get 1 minus x left over. Do you have to do that? No, but be prepared to do it. E to the x squared. So outside is the e to the power still. The inside is the x squared. I think we did this in our notes. Don't multiply anything. That's good. E to the x squared. Aha! This is what a lot of students think was the previous situation, where you had the outside and the inside, the square and the e to the x. But they're different. This would be the outside, this would be the inside. In this one, you could say p prime of x is 2 e to the x times e to the x. Or, you know, if you have a power to a power, that you can multiply the powers. Well, e to the x squared can be written as e to the 2x. You could say this has an outside of e to the power and the inside of 2x. Watch what happens. You get e to the power times 2, or e to the 2x times 2. Well, e to the 2x times 2, that's not the same as e to the x times e to the x. It is. Remember, if you have x squared times x cubed, you'd have x to the 2 plus 3. Well, if I have e to the x times e to the x, it's e to the x plus x, which is e to the 2x. So two different ways to get that same guy. Four to the x squared. Now the outside is 4 to the power. The inside is the x squared. So the outside 4 to the power log 4. Inside 2x. Don't multiply anything because you can't. All right. Product rule. Derivative of the first would be 3 to the 2x log 3 times 2. That's interesting, keeping track of all the numbers. To do that, maybe I'll put it over here. The outside is 3 to the power. The inside is the 2x. So the derivative of 3 to the x is 3 to the x log 3. Derivative of 2x, that's 2x, is 2. So that's why I have 3 to the 2x log 3 times 2. That's just the derivative of the first times the second, plus the derivative of the second times the first. Know that you can't multiply that 2 and that 3. You can't do any of that. I'd probably leave it like that. Maybe be prepared to factor out the 3 to the 2x. And you got, something crazy. Maybe you could simplify this more. Maybe not. Whatever. It's not a product. Don't use the product rule. This is a sum. This is a product. Use the product rule. 5. Either bake it in with the e to the negative x or leave it out altogether. It's up to you whether you want to do that. I like to bake it in, but you don't have to. I get negative 5e to the negative x is the derivative of 5e to the negative x. Again, this is an outside e to the power. But inside is the power. So that negative gets multiplied by the 5. So that's the derivative of the first times the second. Plus the derivative of the second times the first. I don't know, maybe factor out the 5e to the negative x. Negative sine x plus cos x. Maybe we'll need that when we do sine analysis. All right, is the function increasing or decreasing at x equals 1? Well, it's increasing if the derivative is positive. It's decreasing if the derivative is negative. Let's find out. I have to use the product rule again and the chain rule for the derivative of the first times the second plus the derivative of the second times the first. Do I have to factor things out? No, I don't. I could if I wanted to, but I don't have to because I can just plug in 1. Negative 3e to the negative third times negative 3 plus 2e to the negative third. Now I get positive 9e to the negative third plus 2e to the negative third. That's 11e to the negative third, which is 11 over e cubed, which is positive. F is increasing because f prime is positive. F prime of 1 is positive. Don't have to do a full sign analysis if you're just looking at 1 point. Is g of x increasing or decreasing at x equals pi over 3? This is a great one. It's a product, and it's a chain, and there's 2 chains. All right. Derivative of e to the negative x. E to the negative x. Outside, inside. E to the power, negative x. E to the power, negative 1. Sine 2x. Outside, inside. Sine outside. 2x inside. Cosine. 2. Derivative of the first. Negative e to the negative x times the second, sine 2x. Plus, derivative of the second, cos 2x times 2. Don't multiply those together. Times the first. Do I want to factor out the negative e to the negative x? I kind of do, but whatever. Let's just plug in pi over 3. I get negative e to the negative pi over 3 times the sine of 2 pi over 3 plus cosine 2 pi over 3 times 2 times e to the negative pi over 3. Sine of 2 pi over 3 is root 3 over 2. So I have negative 3 root 3 over 2. I said root for all that. And then this is cosine 2 pi over 3, negative a half. Negative a half times 2 is negative 1. Okay. I know I have a negative amount of e to the negative pi over 3s. I know I have a negative amount here. If I add them together, it's definitely going to be negative. So g prime of pi over 3 is negative. So g is decreasing. Or, if I wanted to, I could pull out the e to the negative pi over 3. Know that that's a positive value. And this would be negative root 3 over 2 minus 1. I know that's a negative value. another thing you could have done instead of like looking at it that way. Okay. Well, the location's the type of relative extrema. All right, so we got to look at the signs of my first derivative. Let's find out when they possibly could change. Remember to find where they possibly could change by finding the zeros or the undefines. And for this situation, it will be helpful if we factor out an e to the x. Then we could factor a little bit more. I could factor out an x and an e to the x, actually. I get 0 and -2. Down on my friend, the f prime sign analysis, I got -2, I get 0. E to the x is just positive. We can essentially ignore it because positive, positive, positive. This will be a positive. E to the -1st is positive, so I don't really care about it. This will be a negative times a positive. E to the -3rd, still going to be positive. E to the -3rd is 1 over e cubed. It's a small number, but it is still positive. I get a negative times a negative, so that's a positive. So f is going up, down, up. So x equals -2 is a max. And x equals 0 is a min. Whoa, e to the -x sine x. This will be fun. Derivative first, we've done it enough. I hope we remember and understand why the derivative of e to the -x is negative e to the -x. That's the derivative of the first times the second, plus the derivative of the second times the first. I gotta find when that's 0. Again, factor out. Okay, when in sine and cosine, I'm obviously going to say let's not go from 0 to infinity or negative infinity. I'm just going to go 0 to pi. Point is negative sine x plus cos x equal to 0. So you can think about adding sine x, dividing by cos x. You'd get when tan x equals 1. That's going to be at pi over 4 and 5 pi over 4. So my friend, the number line will focus around pi over 4 and 5 pi over 4 when tangent of x is 1, or when sine and cosine are equal to each other, the opposites will cancel each other out. E to the -x, positive. Ignore it. It's never going to be 0. Plug in values. 3 pi over 2. E to the -3 pi over 2, positive. Sine of 3 pi over 2, negative, but it's like -1 times this negative, which makes it a positive. Cosine 3 pi over 2 is 0. Between pi over 4 and 5 pi over 4, I don't know, pi. Sine of pi is 0, cosine of pi, -1. 0, sine of 0, 0, cosine of 0, 1. There you go. Should have probably used 2 pi. Doesn't matter. There we go. So f is going up, going down, going up. Let's not assume things are going up, down, up. All depends on the situation. Pi over 4 is max. 5 pi over 4, min. Oh, I got this one. Let's examine, by using the product rule, the signs of the first derivative. Okay, factor out. What do I have? Set this equal to 0. See when it's undefined. Don't have to worry about it. There's no denominator. Maybe rewrite this. Maybe factor this. What do we get? There you go. Okay. You think it's a positive, negative, positive? Do you think it's a positive, negative, positive? It is. Look at that. Just so happens. Won't always happen like that. Just all these examples so far have. X equals -4 is a max. X equals 2 is a min. I didn't need this over here, so boom. All right. Increasing concave down. Don't know why I gave you less space for this, but I have two derivative signs I need to look at. First derivative needs to be positive. The second derivative needs to be negative. Let's go. Derivative of the first times the second plus derivative of the second times the first. Factor out the e to the x. Simplify. It'd be 2 plus 2x plus 1. That's 2x plus 3. Set that equal to 0. Solve. I get my friend negative 3 halves. Positives, negatives. Sweet. Second derivative. Which derivative of the first derivative do you want to take? This one or this one? I probably want to take this one. It's a little bit nicer to look at, easier to work with. Derivative of the first times the second plus the derivative of the second times the first. Again, factor out the e to the x. Simplify. It's 2x plus 5. My friends, negative 5 halves, which is a little bit to the left of negative 3 halves, is the second derivative sign that I have to worry about. This is sloppy. Better than this. Since e to the x is just positive, 2x plus 5 is either going to be positive or negative. When are we increasing concave down? We're not. Sure. Well, I ask you what if we are decreasing concave up? That'd be from negative 5 halves to negative 3 halves. So maybe I just picked the wrong sign analysis. Whatever. What is f? Increasing concave down. Find the points of inflection. Find everything. Do it all. Okay. Negative 1. That's important. F prime. Positives, negatives. F double prime. Let's see. If you take the derivative of this or take the derivative of this, I'm going to take the derivative of this. Derivative first times second. Plus derivative second times the first. Factor out the e to the x again. 1 plus x plus 1. 2 plus x. X plus 2. Negative 2. Positives, negatives. So, x equals negative 1. Min. X equals negative 2. Point of inflection. F is increasing concave down. Never. That's funny. Maybe increasing concave up. Let's know. Change it to decreasing. I usually try not give you questions that you can't answer. Decreasing concave up. F prime is negative. That means F is going down. F double prime, whoops, is negative. That means F is concave down, then concave up. F is decreasing. That's from negative infinity to negative 1. Concave down. That is from negative infinity to negative 2. So it'll be negative infinity to negative 2. Sure. Oh, this is a good one. F of x equals x squared times e to the kx as a critical point when x equals 2. Find k. What? All right. Before we just start jumping in, and too many times students just like say, all right, let's take the derivative. But like, think about what's going on. That might help you when you're solving the problem. Critical point when x is 2. So if I take the derivative and plug in 2, I better get 0 or something that's undefined. That's what it means to be a critical point. This is what I need to do. I need to take the derivative. Got to use the product rule. Now, K is a number. That's important. So if I take the derivative of e to the kx, the outside is the e to the power. The inside is like a number times x. The derivative of e to the power is e to the power. The derivative of a number times x is the number. So when I take the derivative of the second piece, I'll have e to the kx times k. Times the first. When this is 2, I better equal 0. Before, I even plug in 2, though I don't have to. I could factor out an e to the kx. I could factor out an x too if I wanted to. But whatever. When this is 2, I get e to the 2k times 4 plus 4k. This has to equal 0. E to the 2k will always be positive. Ignore it. All I need is to figure out when 4 plus 4k equals 0. That is when k is negative 1. I just solved the problem. If k is negative 1, x squared e to the negative x will have a critical point when x is 2. Fascinating. All right, finishing off with some table problems. I got some tables of information. Let's find g prime of 2. G of x is equal to e to the f of x. The outside is the e to the power. The inside is the f of x. The derivative of the outside is e to the power. The derivative of the inside, f prime of x. E to the f of x times f prime of x. What's g prime of 2? E to the f of 2. F of 2 is 0. F prime of 2. F prime of 2. Negative 2. I get negative 2. 1 times negative 2. Oh, look at that. Outside, inside. 3 to the power f of x. 3 to the power log 3 f prime of x. Okay? It's important to do that. Just like it's important to understand the inside is f of x, you got to take and multiply by the derivative. So h prime of x is equal to 3 to the f of x log 3 times f prime of x. That's the derivative of this, minus the derivative of 3x is 3. All right, h prime of 1, 3 to the f of 1. F of 1 is 3. Okay. 3 cubed log 3. F prime of 1 is negative 1. Minus 3. This is times a negative 1. So this is negative 27 log 3 minus 3. Am I going to try to simplify that? No. Leave it like this. This is perfect. You don't know what the log 3 is. It's not something easily found. You just stop there. Quotient rule. Derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. Plug in 3. F prime of 3, negative 3. E to the negative, e cubed minus e cubed f of 3, 2, over e cubed squared. What's that? E to the 6th. So I get negative 3e cubed minus 2e cubed over e to the 6th. That is negative 5e cubed over e to the 6th, which is negative 5 over e cubed. I'd expect you to be able to get that. Sweet. Last one. Product rule, chain rule, derivative of the first times the second, plus derivative of the second, we got e to the power times the derivative of the power, derivative of the outside times the derivative of the inside, times x squared. Plug in 2. 4. E to the, e to the f of 2. F of 2 is 0. Nice. Again, e to the 0. F prime of 2, negative 2, times 4. This is all being multiplied. 4 plus negative 8, negative 4. Thank you very much. Beautiful.